cache of the local storage of the browser, and then every time my app loads, if I need to recall that information, I can just reference that as a JavaScript object. Another example is using the native JSON stringify and parsing algorithm that I talked about before. So you can actually serialize JSON objects instead of just a string. You can input JSON and then get it back out, so more complex objects to store. Session storage, same idea as local storage, but the data is sensitive and it's not persistent. So at the end of the browsing session, it's completely flushed. That would be great for something like a banking session. Last is Web SQL database, and we'll take a look at that, what that looks like. As Mike said, this is something that's been implemented in Chrome, but the other browsers are fairly unlikely to implement it. So the second option is IndexedDB, which is sort of a hybrid of local storage and Web SQL. So the first thing you do, right, it's just SQL. If you're familiar with Web SQL or SQL in general, this will be pretty familiar to you. So the first call to the open, right, you're going to open a database. You're going to give it a size. 5 megabytes is a hard limit in most browsers. Call open, give it a title, give it a description. There's a couple error handlers and success handlers for when things go wrong. Everything is transaction-based. So creating a table is simple as creating a transaction and issuing a SQL statement. So create table. If one doesn't exist, you'll give it a schema, right? A primary key. We'll create a to-do list, give it a full text, and a date time that it's added. And actually creating data is simple as just calling insert with the SQL statement. So pretty cool there. The beauty of the storage APIs is that you can actually see this visually inside of some of the developer tools. So in particular, the WebKit developer tools, Chrome Dev Tools, and WebKit developer tools, you can visualize the data, you can issue SQL statements live, and really debug your application on the fly. Next part of sort of offline is the application cache. And this is something that, in particular, the iPhone and Android clients for Gmail use, not just for storing your assets offline, but recalling those and caching them locally. So when the user first loads the app, it feels really, really fast. So app cache is great because you have complete control as a developer. It's HTML, it's CSS, it's images, it's whatever you want to cache locally and fire up the next time the user loads your page. One benefit is that browser caching is sort of unreliable. So as a developer, we really can explicitly say what we want cached. So here's sort of where the magic happens. There's this, first of all, there's the tag, the attribute manifest that you specify in your HTML tag, just saying this is the file that I want to reference my manifest, the list of resources that I want to cache locally. And then the manifest itself is just a simple sort of text file. So there's a cache line, there's a fallback line, and there's a network line. The first under the cache, that's all the explicit files that I want to serve to the user locally when they're offline. So things like HTML documents, CSS, images, these are just relative paths to the resources. Any JavaScript I want available when my app is running offline. Fallback, so anytime the user is offline, if they hit the root of my site, this example here is just going to serve a static.html page, just saying, hey, maybe you're offline, please fix your internet connection if your internet Wi-Fi doesn't work on stage. And then network is sort of everything else. Anything that needs a network connection that isn't listed explicitly in the cache line or the fallback line, things like login scripts or API calls would need a network connection for that. And of course, there's a JavaScript API for it, right? As with everything on the DOM, there's a JavaScript API. And that's inside of window.application cache. And basically, you have error checking and events for everything, right? When the browser's caching the manifest file, when it's updating it, when it's making the progress happen, when it's ready to be served. And you can actually programmatically swap out when the new application cache is ready. One thing I'll quickly mention is a great tip is the second line here. You can see a date timestamp, basically, and a version number. One thing about app cache is if the manifest file doesn't ever change, even if you change, say, a style in your style sheet, the old version is going to be served to your users. So if you change this file, basically a great tip is just to use a timestamp, right? Maybe write a script to parse out all the files in your application, write this file out programmatically, and then the application will serve the new cache version every time, which is great. I'll just quickly mention that app cache is sort of hard to debug. You don't know really when the browser is doing certain things. The developer tools in WebKit have sort of added this console console statements printing out what's going on behind the scenes. If one file fails, for example, when it's being downloaded, sort of the whole thing, the whole download of the caching of the manifest file fails, which is not too great. But this does give you a little bit more insight to what's going on there. So let's just see a quick demo of App Cache running. So this is a really simple clock app. Just a timer, right? So there's just one JavaScript file. There's a little bit of CSS. There's some obvious HTML markup. And I'm not going to pull my internet connection out because I'm afraid I'm going to lose it. But if I was on Wi-Fi, I would turn this off and then refresh the page. And what's going on is it's actually caching all these resources locally for us. So to prove to you that this is being cached locally, right? First, I specified the manifest file on the top of my HTML. It's really hard to type with one hand. So this is the cache manifest file for this particular site. It's really simple, right? He's got the version string that I talked about. He's just caching the timer.html, the CSS, and the JavaScript of the page. Something else he's doing, if I went offline, he's using local storage. So I can come in here and view the developer tools in Chrome or WebKit. And you can see, again, I mentioned that you can see visually what's being stored in the browser locally to the application. So in local storage here, I can see the domain that's storing what's being stored. But if I was to turn off this application, it's going to cache the resources locally. But he's also using local storage to cache the last timestamp of the clock running. So when I press refresh and I'm offline, it's going to continue on from where it was, which is pretty cool, right? It's a great user experience. So that's a quick introduction to App Cache. A couple more advanced features that I'll sort of skim over since they were just talked about are web workers and WebSockets. Web workers in the fact that, right, we can finally take advantage of a user's full computer, right? We have multi-core CPUs. These machines are becoming faster and faster. It's really great that we can finally, in JavaScript, spawn multiple processes and do a lot of computational work inside of JavaScript without blocking UI. A couple of use cases, why would you want to use a web worker? Maybe you're syntax idling a bunch of text. We do this on our Google code pages all the time. Maybe you're processing large JSON responses from an API call. Image processing large arrays. These are just using the audio APIs that are coming out as part of HTML5. Maybe you're doing some analysis there. Another great example is WebSockets. So we can finally use real-time communication with inside of HTML5. So use cases here, a chat room, a whiteboarding app, which I'll show you. Games is another great example. So the Quake 2 game that was ported from Java to JavaScript actually uses WebSockets for this real-time multiplayer communication. And just to show you, this is what we do sort of today in web apps, right? We make XHR requests, we keep pulling, and that's not a great model, right? It's not a great user experience, it slows things down, we use a lot of bandwidth. Instead, let's open up this bidirectional communication, sort of as a TCP socket, if you will, in JavaScript. So this is an application, and feel free to log on to this right now. It's mrdoob.com/project/multi-user-pad. And this is a whiteboarding application. And basically what he's doing is, you see a few people drawing on here. I drew HTML5 on there before the presentation started. But he's using Canvas and WebSockets to create this multi-user experience. So he's got a chat in the corner, and people can chat in real time. You can see the cursors moving, and it's really, really fast, actually. I was just sitting by my colleague over there, and I could see my mouse almost in real time moving on his screen. So it's pretty cool. So WebSockets, Canvas, I think that's all he's using, but just a great demo of sort of HTML5 technologies working together. Just to prove to you I can actually draw on this. I'm not a very good artist, though. So let's talk about real quick tools and compatibility, because the state of the web today, sort of, we're pushing all these HTML5 features and telling developers use them, but not all browsers are quite there yet. So the Google Fonts API web fonts I talked about earlier in CSS. But this is something we launched at Google I/O this year, and it's really bringing a directory of beautiful open source web fonts to the web. So, for instance, you have a site like this, right? This is a news site. Maybe this is HTML5 say. There's not a lot going on here. You know, we're using H tags and paragraph tags to display the text. But we can really, using web fonts, really enhance this page a lot, making it look like an actual magazine or a newspaper. So you can see at the top there, you know, I'm using a web font that looks like the New York Times font. We've used CSS to style the text using web fonts. There's column layouts. That's another thing in CSS. You can have multiple columns. No more JavaScript for that, which is really, really nice. What else is going on this page? So there's rounded corners, and there's just all kinds of CSS goodness on this page. And really, in few lines, we can transform a site into something beautiful. The API itself, really, really dead simple to use. Basically, what you do is just link to the style sheet that you want with the fonts that you want, so Tangerine here and this other one, and then just use it within the font family of your CSS properties. And then this is an example of what that would look like. So we put a text shadow on it using CSS and use the Web Fonts API to make that text really, really beautiful. The beauty of this is you can make sites like this, and the Chile government was actually one of the first sites that started to use the Fonts API. And all this is web fonts. So all these navigation bars here are using web fonts. The styling here is web fonts, and it's just using the API. But the really cool thing about this is, if you're in Google Chrome, right, you'll notice that the translation